Hello, everyone, and welcome back to Sustainability in Motion podcast. We explore the fast evolving world of sustainability, helping professionals understand how environmental, social, and governance, or ESG practices, are shaping business, finance, and the skills needed to thrive in a changing world. I'm your host, Maria Maisterate, founder of ED4S. At ED4S, we focus on employee scalable sustainability capacity building in finance and in fintech. And obviously, AI has been one of the biggest topics in this area for the last several months. And this is why I'm extremely excited to welcome Minav Patel today to our episode to discuss green AI. What is it? What are the impacts? How big is the problem? And Minav will be introducing a framework that he has developed. And that's exactly how we connected. So Minav Patel is an expert in software engineering, an architect, and a technical leader. And currently he's an engineering manager at Amazon. Welcome to the show, Minav.
Thank you so much for having me. I'm really excited, Maria, to be here.
Great to have you. And so I was so happy to read your article. When I started reading about cost efficiency, business case for sustainable and green AI, I thought we're thinking exactly in the same way. And I thought the framework that you developed in the article that I read was very, very practical. And I'm happy to bring this to our listeners today. Before we get started with the technical stuff, tell us a little bit about your journey. How did you actually emerge from software engineering to thinking about sustainability and energy efficiency?
Yep, sure. So my name is Minav Patel. I am based in Seattle. I have completed my master's in computer science. Currently, I am working as an engineering manager at Amazon. I lead large-scale payments platforms where we process trillions of dollars annually. I have more than a decade of experience in software development and technical leadership. And recently, I've been involved in multiple large-scale projects, specifically driven towards AI. My journey into sustainability started with what I can only describe as a what moment. With the recent AI boom and the large-scale project investments that companies are doing, we can observe that the teams on the ground are continuously scaling their infrastructure footprint to build AI systems and improve the overall efficiency. I started noticing something that really bothered me, that our AI models are getting smarter and smarter, but our infrastructure footprint is getting heavier and heavier. Like every time you train a system or you train a model or you do an inference or you query that model, that all adds up. And the real light bulb moment, I would say, for me was when I read this IMF 2025 report. It talked about that how AI could boost the global productivity by 0.5% annually through 2030. That would sound amazing, but on the flip side, if we don't get the energy piece right, those gains would evaporate. So that's how I started into sustainability, and with my computer engineering background and now working on multiple AI projects, it just connected, all the dots got connected. And just like we design reliability and fault tolerance in a conventional software system, I think there is a need to design for energy efficient and carbon aware AI systems.
Yeah. Isn't it wonderful when those dots connect and you see the new path forward? And it's amazing to see people from actually software development background coming to this realization of limitations of our physical planet, right? And what this means to the growth of some of these technologies. Now let's move to green AI. Can you tell us, is there one definition for green AI, and what does it mean? What does it look like? Are there different shades of green? What are we talking about here?
Yeah, I think that's a great question. There's also a lot of confusion around this topic itself. So let me start with the overall concept of green AI. So green AI is about making artificial intelligence more environment friendly. It's not about producing accurate results. It's about doing that without massively increasing the computational cost. The goal is to make AI accessible to everyone. There shouldn't be a need to invest in massive $1 million infrastructure to build AI models. It's about being smart with resources, not just throwing hardware at every problem. Now, to understand this landscape, I think we should also talk about red AI versus green AI.
Red AI.
Yeah.
Okay, let's talk about different colors. I have not heard about that one.
Red AI is it's what dominating this field. Like it's basically buying better results by throwing massive computational resources at it. So when researchers analyze like papers from the top AI conferences, they identified that most of the practitioners today, 75 to 90%, they prioritize accuracy over efficiency. Meaning there's a lot of computational power that goes into training these large language models, and it has been increasing like 3 to 4 months every 20 from 2012. On the flip side, green AI is about producing novel results while actually reducing or at least not increasing the computational cost. It's about finding that sweet spot where you get great results but do it efficiently. Now, just talking more about green AI shades. Green AI has two approaches in it. There's one called as green in AI, and the other is about green by AI. So green in AI is about making AI systems themselves more efficient, essentially reducing the environmental cost of doing AI. For instance, you design energy efficient algorithms. You choose the right hardware for your AI systems. You pick up data centers which is using renewable energy, or you use there are some technical things like model compression, pruning, quantization to reduce the computational power. So this is all about green in AI.
Okay.
Like how can you make AI systems more green or sustainable or efficient?
Got it. So let me just do a parallel with something we're more familiar with. Green AI is basically using AI, but in a way that's more cost efficient and energy efficient. So a parallel example would be your building, using maybe renewable energy, insulating your building so there's less leakage. So that's green AI. It could be applied in anywhere in AI. And it's just about making it smarter. So just compared to that red AI that you mentioned earlier, this is just basically being cost cognitive. So basically managing your costs, where red AI almost feels like a gambling. Let me throw a lot of money on it. We're just going to go crazy. And then hopefully something amazing will come out of it. Am I understanding this correctly?
That is accurate. I think red AI just talks about just being more accurate, but not efficient. I think we need to get to a state where we are more efficient and we don't compromise on the carbon emission. Then we essentially build systems that are more efficient.
All right.
Touched base on one more piece that I think I talked about green in AI, and there is green by AI.
Yeah, green by AI.
So that is where the magic happens. Essentially, you use AI as a tool to solve the environmental challenges in other fields. So AI essentially becomes part of your sustainability problems. An example I can give is like if you go in agriculture domain, there is something called as precision farming, where essentially it uses AI to analyze data from sensors, satellites, and drones to give farmers specific insights about where to water, where to fertilize, instead of treating the entire field in the same way.
Got it.
It's like more surgical about the resource usage. So that essentially is green by AI.
Got it. Okay, so green by AI is basically sustainability or decarbonization solution that helps others reduce their impacts or improve performance on sustainability.
Right.
But green by AI could also use green in AI in the sense that themselves, they could also be more efficient in how they build those models, right?
That is correct. And both needs to go hand in hand. I don't think so we can just use one and the other. For instance, like if you use AI to optimize renewable energy, but at the same time your AI systems themselves are burning fossil fuels, that's like self-defeating, right?
Yes.
I think the magic would happen when both work together.
Yeah.
You have an efficient AI systems that are solving the real sustainability challenges.
Yeah, and that's actually a great segue to a next question. Talking about what are these data centers are being powered with and the environmental impacts, right? We talk a
Well,
lot about energy, but I feel we don't talk enough about water. So let's jump into a problem. Tell us, how big is the problem in terms of environmental footprint of AI, and what should we know in terms of assessing where could cost reduction come or efficiencies come from?
right.
Where is it being actually produced? Is it more on a training models usage?
Yeah.
What's your take?
Yeah, this is where the numbers get really eye opening. People just think AI is just software or a code, but there is massive physical infrastructure behind every query and every model run. If I can give you some numbers, in the US alone, data centers consumed around 176 terawatt of energy in 2023. Just to simplify that for the listeners, that's like 4.4% of all electricity in the country. MIT research suggests that this could hit 12% by 2028 if we continue to use AI in the same fashion that we use today.
That's insane.
12%.
12%.
Just adding more to it, I think globally, the entire information and communication technology, for example, your phone, your computer, your internet, today accounts for like 3.9% of global greenhouse emission. That's more than all the planes flying around the world. Some projections suggest that AI energy consumption could reach even to 30% world's total energy consumption by 2013 if the same trend continues.
So I'm curious, just to understand a bit more under those numbers, this energy consumption, is it mostly from the data centers? And is it related to training the models?
Yeah.
Tell us a bit of how are the dynamics underneath?
Yeah, I can probably give you examples specific to AI that would take this home. So you all are familiar about ChatGPT. So the model behind ChatGPT is GPT-3, GPT-4, and the new upgrades that they have been doing. A few numbers about GPT-3 model itself. So the training the GPT-3 model required around 1200 megawatt hours of electricity, and it required around 10,000 computer chips, and it produced around 550 tons of CO2. That's equivalent to flying from Australia to UK 33 times. And the GPT-4, the upgrade of GPT-3, it was trained on 570 times more parameters than GPT-3. Now just think about for a second the amount of energy that GPT-3 produced. If you multiply that by 570, I think the energy requirements are astronomical. This isn't about training itself. There's also the inference angle to it. So in January 2023 alone, people accessed GPT-3 about 590 million times. That's like consuming energy equivalent to 175k people using in a month. So every single time someone types a query into ChatGPT for any questions, right? It's like running a 5-watt LED bulb for an hour and 20 minutes. So that now you multiply that by millions of queries per day, millions of users, and you start to see the scale.
So I'm just curious, how does this compare to, like, let's say Google search? If I was to search something, best restaurant in town, and I go on Google versus I go on ChatGPT, how much more am I emitting in terms of greenhouse gas and energy? Both are related, obviously, compared to Google search.
Yeah, I think this is the same example that I gave for let's say the same question that you queried instead of Google search, you queried on ChatGPT. It will go hit the models that are behind the ChatGPT, and it will give you back the query. But that whole round trip and getting that response from that model, it's like consuming 5 watts of LED bulb for an hour and about 20 minutes. That's a lot of energy that we are consuming by querying those models that are running behind the scenes.
Absolutely.
And this is not just about training and inference. I think there's also one thing that we usually ignore is the water consumption, which you also touch based on. The water consumption angle is also important. The data centers that are running this massive AI systems needs a lot of water for cooling. We are talking about millions to billion cubic meters of water annually just for AI servers to run efficiently.
If you've been listening to our podcast, you know that at ED4S, we focus on scalable and customized sustainability e-training for employees. Well, here's something very exciting, especially for your tech teams. Our Green AI course will be available on ed4s.org starting March 1st, 2026. And it's free for the first 100 participants. It has been designed to help teams learn about sustainable and energy-efficient AI in a time-efficient way. So if your organization is interested, feel free to connect with me via LinkedIn or send me an email, maria@ed4s.org. I'd be happy to share more details with you. It's a crazy number. And then when you think about regions when there's already water scarcity and droughts, and how are populations being potentially affected if we are building data centers there. All right, so let's talk about the myths. What are the myths that exist right now about the environmental impact of AI?
Yeah, there are many, but I think I would limit it to two big myths that I can think of on top of my head. I think the first one is that we have to choose between innovation and sustainability. This is the biggest myth in my opinion. It's just not true. There's this great study about small is sufficient that found we could cut the global AI energy by 28% just by appropriately using the models, right sizing the models. We are not talking about sacrificing the capability. We are talking about not using like a sledgehammer when you only need to use like a regular hammer, right? The second misconception that...
Okay, so hold on, Minav, just to make sure we fully understand the right sizing the model. And so can I maybe use that example again of looking for a restaurant on Google? Is that like basically using the right model for the right use case, being smart about which models we're using?
Yes.
Okay. And
yes, that's right.
And does that currently fall to responsibility of the end user, or would it be really more the providers like ChatGPT's responsibility to make this?
It's actually on the end user. The providers like ChatGPT and Claude, the Anthropic, they are essentially providing more models, bigger models, I would say larger models, because there are so many use cases out there. But it's end user who has to choose right model for their use case.
Got it.
You don't have to go for the biggest model or the largest model every time. Just think about what use case you have and then appropriately select the right size model. That itself will reduce the energy consumption.
Yes. So again, unfortunately, extra work for the user to make that analysis and selection just comes to your consumption decisions, right? So,
that's right.
Okay. So let's go to the myth number 2.
Oh yeah. The myth number 2 it's about that we all think that it's all about training big models. I think I touched based on this in the previous question as well. Training gets all the headlines because the numbers are dramatic. But here's what people miss. Inference is also where the real energy costs pile up over time. Inference, essentially, you querying the model itself. These AI services that we're talking about, they run 24/7. They burn energy with every single user query. Day after day, month over month, a model gets trained once, but it gets used millions and billions of times. So it's just not about training models. It's also about the inference that consumes energy.
So building on that, let's move to the principles, because this is the interesting part. I want to make sure we have enough time to talk about the principles that you've outlined. Could you please walk us through them? And so just for the listeners, Minav comes from a software development piece. So he's really wearing this head of the teams that are developing new products, deploying new products, architecturing the products. And so the framework really works for those, right? So walk us through the framework, please.
Definitely. So the framework has 5 layers that align with how enterprises actually operate, from strategy down to day-to-day execution. So the first layer talks about strategic layer. It's about setting clear and measurable goals. This is where everything starts. You need specific targets, not vague aspirations. For example, reduce model training emissions by 30% year over year, or migrate 50% of AI workloads to renewable data centers by end of, let's say, Q3. So those are the real targets that you need to set. You just cannot have vague aspirations. So that's the strategic layer. The second is infrastructure layer. It's about location and hardware aware. An example could be like from a geographic optimization standpoint. Let's say you are training a large language model, and if you run that workload in a data center powered by coal, in certain states like US, you are generating like close to around 800 grams of CO2 per kilowatt hour. But if you run the exact same workload in a place like Norway or Switzerland where they use hydroelectric power, you are generating less than 20 grams. That's like a 48 times difference. So that's the infrastructure layer where you need to be more cognizant about the location and the hardware that you're using for your AI systems. The third layer is about the model layer. I think we touched based on this in the previous conversation. It's about smart design and training. This is all about not over engineering. So for instance, an example would be model right sizing, which we talked about. Instead of always reaching for GPT-4 or the biggest model available, we need to ask the simple question, what's the smallest model that can handle this task? For many use cases, like customer service chatbots or like simple classification tasks or basic recommendations, you don't need billions of parameters. A simple, even the lowest model of GPT-2 or GPT-3 would be really helpful to solve your use case. The fourth layer is about the application layer itself, is about energy efficient deployment and inference. This is where the ongoing day-to-day impact happens. I can give an example of an intelligent caching that you can implement in your applications for AI systems. Let's say you have a recommendation system which is querying a backend storage, and most of the time the calls are redundant. Just add a caching layer in between, and now you're not hitting that storage layer. You're essentially, your round trip reduces. So you're essentially building that optimization at the application layer that also plays a role in dropping the energy per inference.
Is that like now, cookies caching? Is that kind of similar to cookies? Okay.
Very similar to that. Like you don't have to go outside of your application to like backend storage. You can just get the data from like a caching or a cookie layer itself.
Got it. Right? And this is done during the front-end development process, back-end?
It could be anywhere. I think this is like at an application layer. It could be on a front-end application or back-end application. These are small optimizations that you can do to reduce the energy per inference. And I think the impact happens when that request essentially now scales to millions of daily requests. You will start seeing massive savings.
Difference.
The last layer is about governance layer, is about making it more systematic. Sustainability only scales when you have systems and processes that make it more of a routine. For example, in our software industry, I'm sure, and many of the listeners would be aware about DevOps. It's like the operational part of it. Similarly, in Green AI, there is this term called GreenOps. So you need to adopt GreenOps. For an example I can give is like a dashboards or create some kind of a visibility. Like if you have a dashboard in your AI systems that show that, hey, this model X has taken is 75% more efficient than baseline, and this inference service Y has achieved 40% regional carbon optimization. That visibility turns sustainability from an abstract goal into like a concrete measurable progress. So yeah, that's the 5 layers that I have summarized in my framework.
Yeah. And it's amazing how it could be related to running any business. I mean, the first one is basically, let's reduce costs and let's set targets to which we want to be more operationally efficient with our costs. And the second one was reduce the load on data centers. So, if it's maybe customer service, like let's try to solve customer problems more efficiently. So we have less load on our call center, for example. Then he talked about infrastructure location, and that's a hard one to solve. I mean, if you need AI, if you have clients in the US, you can't be too creative on where you're going to place those data centers.
Yeah.
So that's probably a harder one to solve for, right?
To answer that question, today, like the cloud providers like AWS and Azure from Microsoft, they are providing details around which data centers are producing what level of energy. You can actually see those things and then choose to go with the data center which has the least amount of energy. You can rely on some of these cloud providers for your AI systems. You don't have to have your own data centers. When some of these cloud providers have taken these things into consideration when they have built these data centers on energy efficient areas.
Yes. So we're building an application right now. It's actually simulation-based training for financial advisors. And so we get to choose which servers are we using, where the location of the service, right? It's not always flexible, but at least we have kind of a large regional, Europe, North America, is it US or Canada? But then you don't really have transparency on whichever server you're going with. What is the energy source in that location? That's where I feel we definitely need more information to do the right decisions.
I agree.
Okay, so this is very relatable framework. I think it makes total sense. And in sustainability, implementing sustainable strategy governance is really the key pillar, because one time off little projects will not sustain themselves unless there's a whole governance put in place. I'm just curious because in financial institutions, let's say if you want to implement a project, a sustainability project, often enough there's like an upfront cost. And to get, any resources, you need to justify return on investment. Working in a tech company, like from your perspective, do you also need to justify here's upfront investment, this is how many man hours will take, this is the cost saving over 5-10 years? Is this something that's also happening in the tech world, or is it more like, let's be more efficient, let's do it?
No, yeah, I think we do the same thing as you described in your domain as well. I think we have a process where we set some goals, we make sure that we have a good outcomes from those goals, and then we measure those year over year. And we have as I mentioned about dashboards and stuff, we have the leadership level dashboards. The leaderships are accountable to ensure that we are meeting those goals year over year.
Okay, and are those sustainability goals or energy efficiency goals?
They are a mix of both, I would say.
Okay. Yeah, because that's one of the things we were discussing, right? And by the way, for the listeners who are following us, we will be launching a green AI course with Minav based on the framework that he developed. And one of the things that we've been discussing is that what should we call it? Should we even call it green AI? Because there's so much politics involved in anything green right now that, just let's talk about what it is. It's a cost efficient AI and it's all about saving money, right?
Yep. It's more of energy efficiency. So we can also call it as energy efficient AI.
And then water efficiency, another thing too, right? Yep. All right, so let's talk about people, culture, and organizational change. So now you're very much aware of environmental impact. Can you tell me about your team or maybe people just in your network? Yeah. How do they think about this topic? What could be a possible way to adopt green AI principles?
Definitely. And this is honestly the most important question, because you can have like the best framework in the world, but if you have people that aren't equipped and empowered to execute it, nothing really changes. I can break it down into like 5 key dimensions very quickly. The leadership and governance is the number one. Leadership sets the tone. So when sustainability metrics appear on the leadership dashboard, right next to things like availability or cost metrics, everyone knows it matters. Governance wise, we make sustainability part of our standard operating procedures. Like the architectural review boards should require sustainability justification, just like you require security sign-offs. The second thing is about skills and training. You don't need to turn everyone into climate scientists, but people do need practical skills. The key is about bite-sized, immediately applicable things. Let's say if a data scientist can walk out of a 30-minute session, apply what they learned that afternoon, it's working. So that's mostly about skills and training. Third is about make it easy. I think remove friction. This is crucial. Like if checking carbon intensity requires digging through documentation for an hour, it won't happen. So, but if it's right there in your deployment dashboard or your cloud management console, people will use it. The fourth thing is about you need to have this cultural transformation. The best analogy that I can give is like a security. If you go 20 years back, you will realize that security was often an afterthought. It was not part of your requirements and designs, but today it is, and nobody questions this. That's where we need to get sustainability. Like green ops that I talked about should be a natural evolution of how we operate. Last thing is start small, scale fast. My advice would be just don't try to boil the entire ocean. Pick one team, one project, get a quick win, celebrate it, show the cost savings and the environmental impact, then scale that across your organization.
Yeah. And that's a good approach to all the sustainability projects, I think.
That's right.
Amazing. So I think you had some tools or rather questions that you wanted to share with us, which is something very practical that everybody who's listening could actually apply right away.
Definitely.
Go for it.
I think there are a lot of tools out there. There are carbon tracker tool, there is code carbon tool, which you can actually integrate into your deployment pipeline, and it tracks energy consumption, gives you an actionable recommendation. There's also tools like PowerTop. You can just research about it. I think one thing that I would give the listeners back is like when you go back in your workload, in your organizations, just ask these three simple questions. Like, where is this workload running? What's the carbon intensity of that region? What's the energy consumption per inference? And third, is this the smallest model that can achieve the accuracy requirements? I think these three questions will just get you started on just thinking about sustainability in your AI systems.
So Minav, I'll ask you to share with us those tools. The ones that you mentioned are free, or is it licensed?
These are all open source available.
Open source.
The PowerTop that I mentioned is an open source tool for Linux systems. So
wonderful.
The listeners can use it. They can search. There are many tools like this. These are just top tools that I can think of.
Amazing. And so we'll put them in the notes to the podcast and make it available to everyone. The questions, this is such a good, I'm so happy you brought it up, because this is a bit of what we're advocating, and I'm still so impressed how aligned we are in our vision in terms of a culture change. A lot of the time, these individuals that working in big companies have very little impact. Even as a client to a bank, let's say, with a small portfolio, there's not much you can do, but you can ask questions. This is the biggest by far impact they can have, whether it's about environmental footprint or portfolio composition. When those client-facing people are starting to hear, or internal teams are starting to hear over and over, HR teams, these questions come up, it comes up on higher in a priority list. And that's when things gets done. So I can't emphasize enough the importance of asking those good questions. And do please share the questions as well, so we can put them in the podcast notes as well.
Definitely. I'll do that.
Well, it was really wonderful to have you today. Thanks so much for sharing this knowledge, and we'll see you soon.
Thank you, Mario.
If today's episode sparked ideas for your team, visit ed4s.org. That's ed4s.org to explore our customizable corporate learning solutions or book a quick discovery call. You don't have to figure it out alone.